The surface area by T2 measurement method is very similar to the surface area by T1 measurement method. If you look at the fields, you see the number of scans per experiment, equilibration time, anticipated T2 value, bulk relaxation time, specific surface relaxivity, volume ratio are all the same fields that appear in the surface area by T1, with the exception of the anticipated value, which in this case refers to T2 as opposed to T1. In addition, the bulk relaxation time that you will enter will be the bulk T2 relaxation that can be measured with T2 autoparameters. Otherwise, the method approach is very much the same. The equilibration time, again, is the time allotted for the sample to reach the interior temperature of the instrument prior to starting the test. If the interior of the instrument is temperature controlled and at the same temperature as the ambient temperature and the sample temperature, then this time can be set to 0. However, if there is a difference between the two temperatures, it's important to give the sample time to achieve thermal equilibrium with the interior of the machine. Just exactly what that means for your particular sample depends on the sample temperature and the interior temperature of the measurement, but this is an important consideration in method development. In a similar sense, the number of scans per experiment, here the default value is 4, is something that can be optimized for your particular sample. So if your particles remain well suspended for several minutes, there's no harm in increasing the number of scans per experiment to improve the precision of the measurement. So typically these measurements are very fast, less than a minute. So setting the number of scans to 8 or 12 is something that is entirely up to you. The only time that you have to be concerned about setting the number of experiments is when you're working with a particle which settles very rapidly. For example, barium titanate suspended in ethanol toluene. Barium titanate has a density of about 6 grams per cubic centimeter. The viscosity of ethanol toluene is less than 1 centipoise. So if the particles are large, it would be difficult for them to remain suspended. But aside from that, the parameters are exactly the same. Once you've established these particular parameters for your sample, then you can again click on Save Method, and this method will be retrieved for use at a later time.